Our fluorimeter looks like this. It's a very big box. It's computer controlled. To turn on the machine, down here there are 3 switches which are done in order. First, the farthest one. Next, the middle one, which is red. And finally, the white one. So this is the correct starting sequence for the fluorimeter and must be done in this sequence so that you do not harm the machine. The fluorimeter uses cuvettes, similar in concept to those used in a UV spectrophotometer, but all 4 sides are clear in a fluorescence cuvette. Light comes in from the side and you measure the light output from the front face. Light in, light out. For fluorescein, the fluorescence is dependent upon pH, and we want a pH at least pH 7 or above, so I'm going to use this tris buffer here, which is pH 8.5. Minimum volume recommended is a milliliter. I'm actually going to use 2 milliliters. So you can see that fills the cuvette about half full. This fluorescein is at a concentration of 5 micromolar, and I want to dilute that to 0.1 micromolar. That's 100 nanomolar. So that requires 40 microliters of my fluorescein. To my eye, this is a completely transparent solution. I don't see any color in it. The machine, however, will be able to detect the fluorescence of 100 nanomolar fluorescein. The chamber opens here. Inside is a compartment where the cuvette will rest. It doesn't push all the way in as it does in a spectrophotometer. The light source is right here. You can't really see it. The light detector is right there. Close the lid before taking any measurements. Now we go to computer control. Luminous software is the folder that holds the various types of measurements that we can do. The one that is typically used is wave scan. So that brings up this screen here. It also wakes up the fluorimeter. I hear a sound. To start collecting data, we click on this button in the corner that says New. And now it says, what do you want to call this experiment? I will call this experiment, so go test Jan 8. In this case, I could give this a title. I'll just leave it as test. So now you can see there is a graph that comes up, intensity on the y-axis and wavelength on the x-axis. So similar in concept to a UV spectrum, but in this case we're measuring the emission of light, and counts will be how many photons were detected. The controls for the experiment are in this corner here. Typically, the scan mode that you will be using is emission. This means we're looking at the colors of emitted light. We're looking at the spectrum of emitted light. You could, although, choose excitation. You're saying, I want to decide which wavelengths excite the molecule. I will leave this on emission. Data mode, fluorescence. That in some reactions make their own light, in which case you would do luminescence, but this is a fluorescence measurement. The most important control here is this PMT voltage. PMT is photo multiplier tube, and depending on this voltage it controls the sensitivity of the machine, rather like a volume control. Crank up the PMT voltage and you'll get a higher spectrum reading. I will adjust this to 450 volts, which I believe will be an appropriate measurement for this sample. I'll hit apply. Another important tab to click on is this wave setup, because I need to tell the machine what is my excitation frequency and what wavelengths do I want to scan. For fluorescein, the recommended excitation wavelength is 490 nanometers, and I will collect a spectrum looking at the fluorescence from 500 to 600 nanometers. That looks fine. It's going to look at every nanometer between 500 and 600. Alright, that looks okay. So now to actually collect the spectrum, up here is a button that says start and stop, and this will be a mini graph of wavelength versus intensity, and I will click on start. So there you can see it's collecting data there, and it does so very quickly. It takes a little while for it to get started, but once it starts, it's very quick at acquiring data. So here it says the data has been saved, so I say okay, great, thank you for saving the data. So here's my fluorescence spectrum. We can see here that the peak emission is close to 510 nanometers, a little bit between, well, it's between 510 and 520 nanometers is the peak emission. By the time we get out to 600 nanometers, there is no light of that color.